3.4 Zeros of polynomials. All right, use the rational zero theorem to list all possible rational zeros for the given function. All right, so we are going to get a p out of this one, and we are going to get our q out of this one. Okay, and what I mean by p is not literally it's going to be 6 and q, the coefficient. It's not literally going to be that. So let's figure out what p is. So p is literally going to be numbers we can multiply together to get 6. It's going to be both a plus and a minus. So 1 times 6 gives you 6, right? 1 times 6 gives you 6. And 2 times 3 also gives you 6. So p is going to be all these numbers with pluses and minuses, right? Plus and minus, plus and minus, plus and minus, plus and minus, right? So what that gives you is plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. Okay, well, let's see what q is. So q is going to be the two numbers we can multiply together give 1, which would just be, 1 times 1. Just 1, right? Plus and minus 1, plus and minus 1. All right, so p is just simply plus or minus 1, plus or minus 1. And what you do is you want to find p over q. So p over q is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And then we're going to put that over plus or minus 1. Now we're going to simplify this because we can. So if you divide plus or minus 1 by plus or minus 1, you're just going to get plus or minus 1, right? And the same thing with all these, because you have it over plus or minus 1, they're just going to simplify as plus or minus the numerator in this case. So this simplifies to plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So this is the list of all possible rational zeros for the given function. All right, cool. Let's try the next one. Okay, so the next one we're going to get our q from this, 3, and we are going to get our p from the 6. Okay, so here we go. So what we are going to do is we are going to say, first of all, we're going to break apart the p, and p is equal to a negative 6. We break that up into 1 and 6, 2 and 3, with all the pluses or minus, the pluses or minus, the pluses or minus. Okay, so p in this situation is the same as the previous one, in that we have plus and minus 6, plus and minus 3, plus and minus 2, plus and minus 1. All right, so now let's find q. Well, q we're going to get from the 3, and that will give me a 1 and a 3, right? 1 times 3 is 3. So we have plus and minus 3 and plus or minus 1. Okay, so now we put p over q. Well, what is p over q? Well, p over q is equal to the list of plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. I know it went in reverse order before. It doesn't really matter. You're going to simplify them all out. And then plus or minus 1 and plus or minus 3. So we're going to actually list all these out, right? So we have plus and minus 1 over plus and minus 1. But we also have plus and minus 1 over plus and minus 3. We also have plus or minus 2 over plus or minus 1. We also have plus or minus 2 over plus or minus 3. We also have plus or minus 3 over plus or minus 1, plus or minus 3 over plus or minus 3, and plus or minus 6 over both plus and minus 1, and plus or minus 3. Now some of these will simplify, right? Some of these will simplify. Okay, so let's simplify. Plus or minus 1 over plus or minus 1 is simply plus or minus 1. The plus or minus 1 over 3 is going to be simply plus or minus 1/3. Then we have plus or minus 2 over plus or minus 1, which is simply plus or minus 2. Then we have plus or minus 2 over plus or minus 3. Then we have plus or minus 3 over plus or minus 1, which is just plus or minus 3. Then we have plus or minus 3 over plus or minus 3, which is just plus or minus 1. Then we have plus or minus 6 over plus or minus 1, which is going to be plus or minus 6. Then we have plus or minus 6 over plus or minus 3, which gives me plus or minus 2.